Hello, everyone. Welcome back to the Moonriver's workshop. Thank you so much for joining us. And we are thrilled to have an amazing guest join us here today. Cairo works on product at OpenZeppelin. And OpenZeppelin has been around. I'm sure you've heard of them. They've been a previous guest on Moonbuilder's workshop series before, demoing Defender and demoing other different products that they have as part of their large product suite. Cairo specifically focuses on Defender and contracts, so we'll be taking a look at both of those today. And just to kind of give you some background on OpenZeppelin, they've been around for a while, and most Ethereum dApps, as we know them today, really would not exist without OpenZeppelin because they have such robust smart contract templates. They make it easy for developers to get started with contracts and with Contracts Wizard and different products like that. Very friendly to all developers. And once you've got your dApp live, you need to monitor it. You need to update it and check the state of it. And that's kind of what Defender is focused on, is this security platform for monitoring and updating and managing your smart contract, once it is live. Now, I'm just giving a very cursory overview, and Cairo's going to tell you way more. And so we're going to get way more into detail. It is going to be hands-on. And so you'll see a demo on Moonbase Alpha. And, without further ado, I want to pass it over to Cairo.
All right. Yeah, thank you, Kevin, for the great intro and for having me. I'm super excited to go over Defender 2.0, which is basically our completely new version of Defender, which is our security platform for developers. And so, yeah, the first idea of Defender was to basically provide a platform where developers can code, audit, deploy, monitor, and operate with the peace of mind that every operation and activity is done in the best way possible in terms of security and efficiency. So, the process of deploying contracts to mainnet is usually a pretty intense experience, and there's a lot of room for errors. So we try to provide all of the tools necessary for developers to minimize, the issues and also, possible setbacks during the development process, so that teams can go from 0 to 1 as quickly as possible. So the idea of Defender is also to basically cover all of the steps from coding up to deploying. That includes planning, releasing, testing, operating, with multisigs and stuff like that, but also governance in general with, DAOs and, more complex governance contracts that can be, built on top of the contracts library. So the first kind of area that, Defender targets is, the coding and the development phase. So basically, we tried in this new version to tie the contracts library as much as possible with Defender, and that means that we basically develop a GitHub app that for every push to your code, every pull request that you open on GitHub, our code inspector app is going to run a report and analysis on your code, and it's going to generate basically information about possible vulnerabilities, gas optimizations, how you can improve your test in both Foundry and Hardhat. So we try to provide this app for all projects that have the repos on GitHub and can be running Truffle, Hardhat, Foundry, with support for also different types of deployment, testing, such as fuzzing, invariant testing. And I think the most interesting part is that we're trying to find ways, and we're exploring this area constantly, in how we can use our AI models that are trained on the contracts library and production contracts that use the library on chain, to basically provide some of the best insight on vulnerabilities and suggestions to your code. The second phase that we focus on is secure audit. So basically, also Defender is the platform where our clients can follow the process of audits with us. They can have conversations with the auditors, ask questions, and basically have the conversations in one single place instead of having separated chats across different platforms. The cool thing is that this audit module also provides a list of basically progress of the audit, and also the conclusion, the findings, everything that you need to know before the audit is packaged and shipped to you as a final report. The third process is basically the secure deploy. And so this is, going back to the idea that, deploying is, at least in my opinion, the most important phase of a project. we provide, together with the Code Inspector app, a simple way to deploy through Defender. And so, deploying through Defender allows to have, for example, deterministic deployments across, let's say, Moonbase, and you can do a deployment on Moonbase Alpha and also Moonbase Mainnet, and so you can have the same addresses on both networks. And so all of these complexities of managing different deployments across different chains is abstracted by deploying through Defender. Defender also checks for storage collisions. So if you're working with proxies, which is a more of a complicated approach of having upgradability on your contracts, then it's super important that you make sure that your new versions of your contracts are not going to have collisions with the previous versions. So all of this is basically packaged on Defender when you're deploying your contracts. And now the last phase, it's monitoring and operations. So this is everything that happens once and after you deploy your contracts to production or testnet. So this is monitoring your contracts, making sure that the invariants of your contracts are held, that users are not having any failed transactions on chain. We also integrate with Forta, so you can have basically more intelligent monitors. You can basically look for suspicious activity that is interacting with your contracts and try to basically prevent hacks and exploits even before they occur on chain. We also have incident response. We also have automatic actions, so you can automate, let's say, oracles, transactions, and everything that needs to be sent on chain every, let's say, 10 minutes or every 30 minutes. And so I think, in my opinion, the cool thing about Defender is that you have all of the different modules, and you can combine all of them together. So as a simple example, you can combine monitors and actions. So every time that monitor detects something on chain, you can trigger an action automatically, on Defender, and that's going to send a transaction on chain. An example could be if suddenly there's a lot of outflows of a token in a DeFi app, you can basically monitor for that, and every time 80% of the tokens are removed from a pool that could be suspicious, so you can trigger an action that pauses the protocol for that pool, and that could help prevent losses or any type of unexpected behavior from the contracts. Yeah, so that's kind of the main idea of Defender 2.0. It also provides a new completely overhaul on the interface and how we want users to basically interact with the platform. But as a general takeaway, we basically provided a new modules for all of the steps of the development and production process, and also tied closer the relation with the contracts library.
And so in terms of OpenZeppelin Defender 2.0 versus Defender 1.0, so the UI is completely redesigned. There's changes like that, right? Things like that.
Yeah, exactly. So in terms of actually differences between 1.0 and 2.0, the main one is definitely the visual experience, and also the developer experience, which is something that really we try to focus on as much as possible. Aside from that, and to be specific, the code, the audit, and the deployed modules are the new ones compared to 2.0. So 2.0 already had monitor and operations, but now we introduced these 3 new modules for everything before that in 2.0. We also released new pricing plans that hopefully can accommodate different sizes of teams, different needs as well. So we're hoping that now there's a pricing tier for each team that wants to use Defender and with different scalability needs.
And so I have a couple more questions. So in terms of, so we talked a little bit about the specifics, right? What was your philosophy, or what was kind of like driving the architecture change between Defender 2.0 and 1.0?
Yeah, totally. Good question. Yeah, it was mostly a consideration on the developer experience. I think today sometimes with so many different frameworks, and you can compare Hardhat, which is on JavaScript or TypeScript, versus Foundry, which is on Solidity. For new developers, the experience can be somewhat complicated. There's a lot of different moving parts. So that was kind of the mindset that we wanted to have for Defender. How can we make the experience of launching dApps and applications on blockchains much more easier, and also safer in general? Over the past year or two, there has also been not only exploits at the let's say logic level, but also exploits because misconfiguration of protocols. Like suddenly the team forgets to initialize a certain contract, or the variables of the contracts are not set correctly, so that can lead to certain unexpected edge cases. So we try to prevent those scenarios with Defender and make it as easy as possible for users to get started in the space, while also being keeping them safe in terms of launching dApps and updating those dApps.
Oh, for sure. And for users who have been around for a while, what does the migration process look like for moving from Defender v1 to Defender v2?
Yeah, so we are deprecating, and as of now, Defender 1.0 is accessible, but we're deprecating 1.0 on June 1st. So from June 1st onwards, all of the users will be using Defender 2.0, which will become just the Defender version, the only version of Defender. So we recommend all of the users to migrate now. We provide, if you log into Defender, you will get a message that recommends you upgrading to 2.0. And if you click on yes, it's going to take you to our onboarding process, which is a few steps on the interface that shows you where you can find the previous components and where there are on Defender 2.0. We modified the interface a bit, so we try to make it as easy as possible to find relayers, actions, and everything else on the new 2.0 version. On June 1st onwards, the users that haven't migrated, we will migrate for them. So for that reason, we recommend all of the teams and users to, if they can, migrate before June 1st, so that they can start using Defender and they can have more of a custom onboarding process rather than us migrating all of the remaining users.
Makes sense. Makes sense. I have a bunch of standing like tasks and things like that from v1 that I probably need to migrate over.
Yeah.
Yeah. So I'll take care of that. And yeah, just to sort of visualize for our audience here, what is maybe perhaps like an interesting use case that you've heard of people using Defender for, or what's maybe just an example of what it's typically used for?
Yeah. Well, Defender is like a Swiss knife. So there's a lot of different use cases that Defender can be applied to. I think what I really like most is oracles using Defender for automation of prices on chain. So basically these oracles teams, they combine monitoring on chain and they check for deviation of the prices. And if suddenly prices of the oracles deviate by a certain threshold, they then trigger an update on the prices on chain. So I think using Defender for that solves the issue of having to make a custom implementation for oracles from scratch off chain. Usually, like the old way was running this stuff on AWS, having to basically create listeners on chain and stuff like that. And with Defender now, the experience is much easier because you don't have to actually code a lot. You just code and you just also choose what you want to monitor and how you want to respond to the monitoring triggers. So in that sense, the experience is much easier. And so I think it's an example of a complex use case, but now with Defender, it becomes more of a simple plug and play example.
Oh, for sure. For sure. And as we see, there are growing numbers of different oracles, right? There's especially for app chains as well. Like there are ways for users to spin up their own oracle using different providers, and so the ability to have this is really important. I see. Yeah,
and I think also I heard about some specific users using I think it's called the XCM protocol to send basically cross-chain messages, and that is combined with Defender, and so you can have cross-chain communication on Moonbase with this protocol, and you don't have to basically do everything custom outside Defender. Defender allows you to do this cross-chain messaging based on activity on chain. So if you have like bridges or you have like certain interoperability that you want to have across different chains, you can use Defender with this XCM protocol, and it's much easier to basically combine those components together.
Oh, that's extremely exciting. We should probably add a note about that. in our docs.
Mhm.
That's all the like the questions I have for OpenZeppelin Defender for now.
Sweet. Yeah, I think we can now move on to a demo. I prepared basically like a demo on the new feature, focusing on the new features of Defender 2.0 and how we expect users to use Defender for deploying. So if now we move on to Defender 2.0, basically the idea is to showcase first. Let me just go on Defender v2. So the idea is to showcase Code Inspector, to showcase deploy, and also go over monitor and actions. And so this is basically how Defender 2.0 looks like. We have our billing and profile here, but we also have manage. And so manage is basically sort of the central settings panel where you can go over the different components of your project. So you can have relayers, which are basically EOAs that are managed on Defender. And so I have one here for this workshop. It's called Defender Workshop on Moonbase Alpha, and also have one for Sepolia. You also have approval processes, and in a simple way to understand approval processes is basically how do you want to use multi-sigs, relayers, and like other examples could be Fireblocks to basically approve activity on chains and on certain contracts. So you can basically create an approval process for a relayer, and that means that you are going to use a relayer to send a transaction with actions, for example. And you can also use saves or different, platforms. We also have the notification channels. And here, I think this is also really cool about Defender is that we support a ton of different platforms from email, which is I think the most simple one, up to Telegram, PagerDuty, Datadog, but also webhooks. So if you have more of a custom, platform or even your own platform, you can use webhooks to connect to that instead of using a predefined notification channel.
Yeah, this is huge. So you have a ton of customizability with the webhooks, and then also PagerDuty is a huge one, Slack. So whatever works for users, right? Like some people might take a Slack notification more seriously than like a Discord one, right? And so I'm a huge fan of like all the customizability and flexibility that you offer here.
Yeah, totally. I think all of this ties back to kind of that Swiss knife idea of Defender. Also, we provide API keys, and we have the Defender SDK. So if you want to run a certain activity on Defender, like making deployments outside Foundry or Hardhat, if you're not using those frameworks, you can still use Defender and you can still deploy through Defender using the Defender SDK and the keys. So in that sense, the level of and the flexibility of customization is really high, and I think that's very useful for a lot of users. So we have the address book, and here we basically have the list of our contracts that we deployed. I have a couple of examples that I was testing earlier. And now, over the past few weeks, we recently released some new features, which is forked networks and private networks. And I think this is really great because previously on Defender, you had to wait until we release support for a certain network. If there's like a new network that you want to use and we haven't yet supported that, then you have to wait for us. But now with forked and with private networks, you can import that network on Defender, and you can create and you can play with your Defender setup on that network. And so you don't have to wait for us to roll on support. Even if you, for example, even if you are, let's say a network developer and you have your own blockchain network and you want to make sure that your own contracts, the bridges, the messenger services are working, you can import using, for example, private networks and basically, run monitors, run actions on this network. We support, for example, so API keys. So if the network is gated, you can still pass the key to Defender, and Defender will use the key to access that network. And also, last but not least, we also have Defender as code. So Defender as code is basically a serverless framework plugin. So you can run all of your Defender operations without accessing the UI. And so this could be interesting for more complex architecture and infrastructure, where you can have your own basically combination, different components in Defender without needing to go to the interface. Sometimes that could be easier for larger teams or larger projects, which it's a bit of a hassle to manage the credentials for the different accounts on Defender. You can just use Defender serverless, and that makes that process easier. Great. So now moving on to Code Inspector. So this is now on the secure code phase. The idea of Code Inspector is that we provide our own static analyzers and AI models at your disposal. So if you want to, for example, get vulnerability information about your contracts, we provide this tool for you. And so, Kevin, I don't know if you remember, but on November, there was like a third web a scenario where, there was like a dangerous combination of ERCs. It was, I think, multi-call and forwarder. And basically, it was really hard for some projects to determine if their contracts that they were using were vulnerable or not. So in those days, we deployed a new rule for Code Inspector that allowed teams to know if their contracts are vulnerable. So as us internally and also externally, we keep finding vulnerabilities out in the open. We roll out support with rules on Code Inspector. So you can always, get the latest information about the contracts, both on GitHub and also on Etherscan or any explorer that has your code verified. So here's an example. I have my Defender demo repo on GitHub, but I can also add a contract here. So you can look for a contract that you want to basically run a report on. I have, a box implementation. I have this box implementation, and you can select those contracts to import to Code Inspector, and then you can trigger a report on those assets. So, for example, here I'm just going to select my GitHub repo. It's going to pull the branches and the commits for you. So this is just going to pull the different branches. I'm going to select Foundry, and now this is also going to pull the comments. So I'm just going to select the latest commit here. And so if I trigger this, now this is just going to run a report, and it takes usually a few minutes. It depends on your configuration of Code Inspector in your repo. And the reason that I'm saying this is that we have, I think, over 60 rules. And so, if you would like to, disable certain rules, you can do so on the configuration of the repo on GitHub. And basically, Code Inspector is just going to listen to that and follow, the criteria that you selected. Some examples of how a report look like. This is basically one for the same repo, and so it provides details on vulnerabilities, errors, how can it be improved. Also, it detects if it's an upgradable contract. For example, here I'm missing a storage gap variable to prevent the storage collisions. So it gives that sort of general information, not only on vulnerability, but sometimes on test and also gas, when it detects, let's say, very inefficient loops or very inefficient implementations. It's going to recommend alternatives for you. And so I think this, in general, Code Inspector, I like to combine it a lot with GitHub Copilot. And so you have that experience of, having AI recommendations on your IDE, but also once you push your code, you also have, this summary that the Defender generates for you, so you can get information on here. Yep. So this was basically Code Inspector, and now moving on to deploy. Basically, Defender allows you to create two environments, and the reason is that we want to make sure that developers, they don't deploy test contracts on production or production contracts by mistake on test environments where they expected to deploy on production. So this basically separates the two environments and kind of maximizes security for that. So we're going to just an example. We're going to go through the test environment setup. So how it works is that you select a few networks that are test nets that you want to deploy your contracts on. So we can look for Moonbase Alpha here. And now we're going to choose the deploy approval process. So as I mentioned earlier, approval processes are, a way of, certain assets on Defender to be used to do certain activities. So as I showed earlier, we have a relayer with some native gas token that we can use. And so now we're just going to create an approval process. We can do it through here. You can select the name, and you can also select the address. But just an example, we're going to go here, create an approval process, and we're going to say Defender Workshop approval process. We're going to select the network. We have also Moonriver and Moonbeam, but this is the one that we're going to choose for testnet. And here are all of the examples of different assets that we can have as approval processes. We can have multisigs, EOAs, relayers, governors, time locks, and also fire blocks. For this example, we have a relayer. So we're going to choose our relayer that we showed earlier. So this is just going to create the approval process. And now, once this is ready, we can head back to deploy and use it on deploy to deploy contracts. So we have it here, and we can also see the type that is relayer. And now the final step is for upgrades. So Defender allows you to basically choose a different approval process that you want to use for upgrade. So usually what's most common with this module is that teams deploy with a relayer, but then use a multisig as owners of the contracts. And so only the multisig can upgrade the contract usually, or another example could be the governor. For this example, we're just going to skip this step. But you can also go to approval processes and create the approval process that you want. Great. So now we have the keys, and we can basically now move on to the IDE. So I'm gonna move on my screen. Perfect. So yeah, so we're back in the IDE. We are first going to go to Defender. Let me just move this here. And we're going to copy the API key. So yeah, now we move on back to Defender. We're going to copy the API key, and we're going to go to our IDE. So I have this example, which is the one that I also use for Code Inspector. So we have a box contract, and this is an upgradable contract that basically has a number of objects inside this box, and anyone can remove or add objects. It's upgradable, and we also have box B2, which is another version that we want to use after we deploy the box contract. So the difference is that this B2 adds a new function called add object. And so now the implementation would be not only removing, but also adding objects to this box contract. So we're going to go to our environment variables. We're going to paste our API keys. And now we have everything ready to deploy. So going back to the IDE, we have this deployment script. As an example, we recently released OpenZeppelin Foundry upgrades, and so you can do upgrades on Foundry through not only through Foundry in general, but also you can combine Foundry and Defender. So this is I have it commented here, but this is an example on how you can get the approval process address from Defender on Foundry, and you can use, for example, a lot of different logic. You can use, this deploy approval process as the owner of the contract, so you have a lot of flexibility to use the data from Defender. For simplicity, we're just going to remove this, and we're going to deploy our box contract. And so if you notice here, what's useful about our plugin is that you don't have to deploy the proxy and then the implementation. The process is completely abstracted by the upgrades library, so you just simply call this deploy UUPSP proxy function, just pass the box file and also the parameters that you want to initialize, if you have an initializer or not. So if we go back to the terminal, we are going to run force script deploy, and we're going to just run force in case. And now we're going to have to pass an RPC URL. And so how it works is that Defender is going to use this RPC to notice what chain ID you are using to deploy. So, if you're using a RPC for Ethereum mainnet, it's going to detect that, the chain ID is 1. And so it's going to get the approval process for chain 1. So if we go back to Defender, we can see that we have Moonbase configured. We can, go to chain list, get basically an RPC. We can use, let's say, this one right here, or this one. And we can go back to the sender. We just paste it. And now if we click on here, it's just going to send this deployment request using Foundry to Defender. This depends on the network and also, the configuration. We provide automatic Explorer verification for pro tiers. But if you're on the free tier, you can go here and pass your own key for the Explorer. And so that's going to basically automatically verify the contract on Explorer using that key. Just for the sake of time, we have two examples here of deployments. We have the box implementation, and also then we have the proxy. And so first it deploys implementation and then deploys the proxy, which is going to point to the implementation and it's going to delegate all of the calls to the implementation. Now, if we click in one contract, for example, the box contract, it's going to highlight some of the general data about the deployment, the deploy approval process, the status, and the verification on the Explorer. We also have the state. So we have the interface version, the number of objects, the owner, and the ABI as well. So now, as we can see that the owner is the 0 address. That means that we didn't initialize the contract. So now what we're going to do is that we're going to use actions to basically initialize the contract and set ourselves as owner. Usually, and this is what we recommend, is to initialize the contract as soon as you deploy, or in the same transaction as you deploy the proxy. And the reason is that, so that you don't leave room for other people to initialize your contract. But just to showcase action transaction proposals, I think this is a good example. So we have actions. Actions in general are, on-chain transactions, but actions, the default method, are automatic transactions. So I have 3 examples here of webhook, another transaction that runs every minute, and another using webhooks. So I can go and create an action. I can say, for example, send an Oracle update every minute. And then you can choose to schedule this every minute. And then you can connect to a relayer. So we can say that we want this Moonbase alpha relayer to send this transaction every minute. And then you have, the code that is going to be triggered by this action every minute. And so here you can, send, the update on chain. You can, do computations. In the example that I gave earlier, the teams that have oracles to update, here they usually calculate the deviation that they have on chain versus the one that they want to send or to update. So you can do all of the logic here. You can do, you can use libraries. You can use dependencies. So we provide ethers.js. So you can do any type of activity in relation to contracts. You can also do cross-chain calls, everything from this piece of JavaScript code. But going back to our deployment contract, we have to initialize it. So if we go to manage and we check our address book, we can see that we have the box implementation and the proxy implementation. So if we click on the proxy, we can basically get some data here. We can get the ABI, the address, the state, but also it's going to analyze the address and it's going to detect if it's upgradable or not. So if we check the ABI, you can see that it contains the ABI of our implementation. And the reason is that this proxy is pointing to the box implementation, so it automatically gets the ABI. So it's one less step that you have to do to get the ABI and update this to the proxy. So if we go to transaction proposals are, let's say, on-demand actions. So they are a manual approach to actions and usually used to do, single transactions on chain. So this is a good example. We can call it initialize contract, and then we can choose our proxy as the target. And so this is now going to fetch the functions from the API. And so the function that we're looking for should be initialize. And so now we can pass it, let's say, 5 objects. And now we can choose who is going to be the multisig or the owner. For simplicity's sake, we're going to choose our relayer to be the owner of the contract. And then for the same reason, we're going to choose the relayer to send a transaction on chain. And so now we're going to submit this transaction proposal. It's going to do some simulations to make sure that it can succeed or not. It's also going to calculate the gas for you. So in this case, it cannot estimate the transaction, and it's going to give you a reason for that. If the transaction is going to fail, maybe the relayer doesn't have enough funds, or maybe the contract was already initialized, you can still, let's say, force the transaction to send on chain. And this is an example of a transaction that is going to be sent on chain, but because the contract was already initialized here, right here, when we deployed the proxy, this is just going to be a transaction that reverts on chain. Okay, so that's an example of transaction proposals. Now we have workflows, and so workflows are basically a way of doing incident response for your contracts. So you can combine the different action and different templates for your contracts. So you can make, for example, you want to remove an object, then you want to remove another object, or maybe make both actions in parallel. So that means that if one of these actions in parallel fails, the workflow is just going to continue anyways. However, if you have one single action, so for these first two, if the first one fails, the workflow is just going to stop and it's not going to finish. So this is a good way of setting up incident response for your contracts, where you can combine monitors and also actions and create different combinations in general. Great. And now moving on to access control. So access control is basically a way of having visibility on the permissions and the roles of your contract. So if your contract is, for example, inheriting the access control library, you're going to have different roles. So you're going to have the admin role, you're going to have, I don't know, as an example, the minter role. So you can have all of the different roles. But the problem is that it's really hard to have visibility on what addresses have certain roles. Or rather, if a role has even a certain address, maybe it doesn't have a new address, so it has to be granted or revoked. And so we can see the two examples here. We can see the proxy, and we can also see our box contract. So we can see that the proxy has ourself as the owner, which is the relayer address. We can click it, and basically, as long as we use an approval process that is the relayer, we can replace the owner, and so we can give the ownership to, let's say, another contract. We can give ownership to USDC coin or whatever address, and we can basically use this relayer, send a transaction, and it's going to basically change the ownership for the user that is the current owner. And so we have a current proposal which is initialized, so we're just going to approve it and send it. And now once this is sent, we have the proposals queue clear. And the reason that there's a queue is so that basically you can have teams send different proposals at the same time, and you can manage what proposals you want to execute or what proposals you don't want to execute. So it's a way of making sure that you don't approve and send proposals by mistake. So the reason that this is failing is the same reason that I explained earlier, which is the contract is already initialized. But in case that it's not initialized, or in case we have an empty queue, you can basically change the owner with this access control view. And also quickly, we can go over monitors. And so monitors is basically, it's basically a way of getting and analyzing data on chain. So you can set up monitors for ownership changes. You can set up monitors for if a contract is paused or not. For certain activities, you can also monitor for ERC20 transfer or NFT transfers. And we have a series of templates. And so it's going to look for your contracts on your address book, and it's going to basically detect which ones are compatible with the different templates. So we have our two implementations here. We can see that one of these two is the one that we deployed a few minutes ago, and the other one was the one that we're using for the demo. And you can basically click here, and it's going to apply this template for the contract. So you can have monitor for ownership. You can select how many confirmation blocks you want to have. So let's just choose one. You can also select different transaction properties. So if you want to make sure that the value is, let's say, more than one ETH, or more than one, whatever the gas token is on the network. You can also have the gas limit and different filters that you want to look for. You can also look for the status of the transaction, so you can skip, or you can even look for reverse. So if you want to have successful transactions only, you can basically filter like this, and that's going to be included as part of the criteria. Or you can also have a JavaScript code, basically as a custom filter for the monitor. So now we can select the events. Because we were using this ownership template, it's just going to automatically select this ownership transferred event for us. But we can select the initialized event or the upgraded event. And here we can look for specific parameters that we want to make sure that match in the event. So here you can have a custom address, and the same idea for functions. You can combine functions and events, and you can make sure that you're looking for, I don't know, one function that emits certain events. So if you have a function that emits multiple events, you can do a combination of both to look for what's needed in that function. And this is going back to notification channels. Here you can basically decide where you want to receive your notifications for this monitor. I have two examples here. I have my email for my account, and I also have a Telegram bot. And so I did a couple of tests and examples with Uniswap. So an idea is that you monitor a Uniswap B3 pool. And so every time a swap happens, you receive a message on Telegram. And so you can do some interesting ideas. You can do some maybe arbitrage bot, or you can do some rebalancing bot. So there's like a bunch of different use cases that you can use the alerts and the monitors for. In that same idea, you can execute an action based on a monitor. So if in the case of Uniswap, if there was a swap in certain pool, you can trigger an action. So you can trigger another swap in that same pool, or you can trigger another, I don't know, maybe add liquidity to that pool, and maybe it's missing more liquidity. And so there's a lot of flexibility in how you can make different combinations. And yeah, there's a few other things. You can set the alert threshold if you want to only receive a few alerts, and also the security label. But those are the main modules. There's a few things that I didn't go over, such as audits or logs, but those are more specific, I guess, examples. And yeah, just going back to the beginning, we have the overview page. And here, this is basically provides a high-level perspective on the status of your protocol or your tab. You have the code inspector reports. You have how many contracts you deployed, your active monitors, actions, workflows, and also how many contracts you are managing on access control.
Oh, sick, Cairo. So as everybody can see, right, tons of customizability, tons of different options. You have all the choice in the world for your configurations, for your setup, for your notifications, like what actions you want to take. And it seems like everything works together really, really nicely, right? So the different types of proposals that you have and the different sorts of responses that you have and alerts and all that, like everything seems really well, integrated together, like tightly coupled. I don't see these as like different products where somebody only uses one, but somebody uses probably, several different, ones of them at once. That's what I see.
Yeah, totally. Yeah, I think the idea was also to try to make each module connected to each other. So if you have certain activity on Code Inspector, and this is an interesting fact that if you're a client of us, which is using Code Inspector, right, and you're also going to do an audit with us, you can choose the auditors to receive the data from your Code Inspector reports, and that's going to help with the auditing process. So that's going to bootstrap the auditors faster, because they're going to leverage the reports that you generated with Code Inspector before. So that's kind of an example of how we tried, and we give the tools for the users to decide how they want to combine each module and each feature on Defender together with each other in general.
For sure. Cairo, what's the best place for people to learn more? Is it to go to the doc site, like for tutorials?
Yeah, exactly. So right here on the top right, you have a docs. So you just can click here, and we try to keep the docs up to date. Here you can see the notice for the Defender 1.0 deprecation. You have a page for each module, and explains everything more in detail. As an example, we have for Code Inspector all of the rules here, and also how to basically create configuration for different modules in general. We also have tutorials. So pretty similar to each module, we try to have a tutorial that explains how to deploy a contract or how to monitor a contract with the different modules. So in this example of deploy, we have an example with Foundry, and also we have an example with Hardhat. We also provide guides. So guides are basically more concrete ideas or more concrete examples that not necessarily use only one module, but rather multiple modules on Defender. So a few examples that I really like is, for example, relaying gasless meta transactions, using photobots. And so we provide, more complex scenarios that you can play with, and you can learn more about how to combine the different modules. We also provide the right here the documentation for the SDK and the API. So if you are more of a developer that is interested in more complex scenarios, we recommend using the Defender API and the SDK. And we also provide a migration guide for the users that want to move from Defender 1.0 to 2.0. And here we display all of the differences between the two versions, where you can find the new features, where you can find your assets, your contracts. So everything is explained here. But as always, on Defender, you can reach out to us right here on the bottom right. Clicking here, you can send feedback, which is super useful to us, and you can report an issue or ask for even new features. And we try to respond to these submissions as fast as possible.
Oh, that's awesome. That's great to hear. I'll be sure to leave the links to OpenZeppelin docs on the video, so folks can see that there as well.
Yep, perfect.
Cool. Well, thank you so much, Cairo. This has been a huge thrill to have you here, and thank you so much for the very in-depth demo. Appreciate that you showed all the different products, and you went through all this on Moonbase Alpha. And for the audience here, right? OpenZeppelin supports Moonbase Alpha, Moonriver, and Moonbeam. So if you're trying to test stuff in a test environment first, you can do that before you go on to Moonbeam or Moonriver, or both. And so we appreciate that flexibility. I know developers appreciate that flexibility, and supporting all the different networks is a huge plus. And so, yeah, we're thrilled that you do.
Yeah, no, exactly. Also, there's a possibility of importing your own. If you are debugging on testnet, you can use Tenderly, or you can use other platforms to generate your own fork network of Moonbase, let's say Moonbase Alpha, and you can debug on that fork with Defender. So we provide, also a way of debugging testnet or production. But in general, that's exactly right. We support those three networks, and so you have all of the modules totally available on those three on the three networks.
Yeah, the new forked network feature that you have,
yeah.
that's a huge feature. That's great to hear. And we'll be sure to enhance our docs on the Moonbeam docs site for what we have for OpenZeppelin.
Amazing, perfect. Yeah, thank you so much.
Cool. Well, thank you so much, Cairo. Thanks everybody for joining us, and be sure to stay tuned for an upcoming Moon Builders workshop. We hope to see you back here very, very soon.